Harvey, are you alright? It's your scar again, isn't it?
Yeah, you know who is really upset about something. Why? What did you see? Well, it's some kind of cryptic diagram. What does it mean?
Honestly wrong. Don't you ever read? That's clearly the Circularum Unitatis.
It just looks like the unit circle to me. Never mind that. We don't have time. You know who is trying to find all the rational points on that circle. Rational points? Yeah, you know, points like 1, 0 and 0, 1, where the coordinates are both rational numbers. But why does you know who want to find them? I don't know, but if he does, they must be important. We have to find the points before he does. Well, let's get going, mate. You've already found 2, 1, 0 and 0, 1, and by symmetry, -1 and 0, and 0, -1. There are 2 more. That's 4 down. How many more can there be?
That's just it, wrong. Even if we find more, how can we be sure that we have them all?
What about magic? Isn't there some spell you can use?
Maybe, but wouldn't you know who have tried that straight away? I guess it wouldn't hurt to try, though. Rationalis Revilius.
Blimey, looks like every bloody point on the circle is rational.
No, there are loads of points that aren't rational, like 1/2 and square root of 3/4, and 1/3 and square root of 8/9. In fact, for any x between -1 and 1, the unit circle equation x squared plus y squared equals 1 gives y equals the square root of 1 minus x squared. But if x is a simple fraction, the y's are almost always irrational. No, I think that what the spell must be showing is that the rational points are packed so closely together that it's almost impossible to distinguish between them.
Is you know who looking for irrational points too? No, they'd be useless to him. You know, a line between 2 rational points always has a rational slope. How's that? Well, like 0, 1 and 3/5, 4/5. They're rational points. And the slope between them is 4/5 minus 1 over 3/5 minus 0. All the numbers in there are rational. So when you work out the result, it's sure to be rational too.
Okay, but where does that get us?
Well, maybe if you draw a line with rational slope through one point, say 0, -1, it'll intersect the circle in another rational point. Then, by drawing lots of lines with rational slopes, you can find lots of rational points.
Wrong. You're confusing the converse and the contrapositive. It's a classic fallacy.
You mean just because slopes between rational points are rational, that doesn't mean it works the other way around. Just starting with a rational slope from a rational point doesn't mean we'll hit the circle in another rational point.
Exactly.
But Wrong's idea is still a good one. If we could generate new rational points his way, the fact he gave us guarantees that we'd be able to find them all that way. There would be exactly one for every rational slope. Yeah, that's what I meant. Thanks, mate. So let's have a go at sorting this out. We may not have much time. Does drawing lines with rational slopes always lead to points on the circle that are rational? Let's try a few examples.
Start with a line through 0 and -1 with a slope of 1/2. Its y-intercept will be -1, so its equation is y equals 1/2 x minus 1. It generates a new point of intersection at the simultaneous solution of the line and the circle equations.
But how did you get that? Wrong, Hermione, focus. We have to solve this before Voldemorphism does. Remember what happens to everything he gets his hands on?
Yes, he maps it to he maps everything to...
To evil, and there's no inverting it. I think you were about to say you used substitution, is that right?
Yes, of course. And equation 1 is a quadratic, so we can expand it and apply the quadratic formula. But that just gives us a formula to find the points where the line intersects the circle. It doesn't say they're rational. There's a radical in the quadratic formula, you know. That's generally a sign of irrationality.
But we don't need both roots of the quadratic. We already know that 0, -1 is one of them. And we just want the other one.
Wrong! That's it!
Why are you always so surprised when I have a good idea? Remember, we're kind of in a hurry here. What did you just realize, Hermione?
The roots of the quadratic equation Wrong was interested in are the x-coordinates of the 2 points where the line intersects the circle. But we already know that one of those points has x equals 0. That means 0 and the root of the quadratic has to factor in the form ax times x minus b. And since that process doesn't involve taking a square root, the other root will also be rational. We've proven Wrong's conjecture!